Hey there, and welcome. We're about to jump into a coding technique that can make your big data jobs way more resilient. If you've ever had a huge import fail because of one tiny error, you know exactly how frustrating that is. So let's talk about how to fix that for good.
Oh, you know the feeling, right? You're importing 1,000 new contacts, you hit run, and nope, crash. The entire job just fails because one single record had a typo in an email address. It's super frustrating, totally inefficient, and yeah, it's an incredibly common problem.
Well, this whole scenario actually has a name. We call it the all-or-nothing trap, and it's all because of the default behavior of DML, that's data manipulation language. Think of your basic insert, update, or delete commands. Let's kind of pull back the curtain and see what's really happening. So by default, these operations are what we call atomic. Just imagine a chain with, say, 100 links. If even one of those links breaks, the whole chain is useless, right? It's the exact same thing with your code. If just one record in your batch of 100 has an error, the database says nope and rejects the entire transaction. Nothing gets saved.
And this is the part that really stings. It's not just that the one bad record fails to save. No, every single record fails. Those 99 perfectly good records you tried to save, gone. It's as if the whole thing never even happened. A total all-or-nothing failure.
But what if there was a way to escape this trap? Well, there is, and it's a pretty elegant solution that lets us save the good stuff and just gracefully handle the bad. So let's introduce the hero of our little story.
Say hello to the all-or-none parameter. It's this optional little setting in a lot of database methods, and it does pretty much exactly what it sounds like. By just setting this one thing to false, you're basically telling the database, hey look, I know some of these might not be perfect. Just do your best, save what you can, and let me know which ones didn't work out.
Okay, now this slide is awesome because it shows just how much things change. On the left, you've got the default behavior. You hit a snag, you get a big angry exception, and everything rolls back. Poof, gone. But look at the right side. When you set all or none to false, the whole game changes. The operation doesn't throw an exception. The valid records actually get committed, and most importantly, you get something back, a detailed report card on every single record you tried to process.
So theory is great and all, but let's see how this plays out in a real-world situation you're definitely going to run into, a big data import. This is where partial success goes from being just a neat trick to an absolute must-have.
So let's just imagine a pretty common task, right? You've got a list of 100 new leads from some other system, and you need to get them into your database. Seems simple enough.
But here's the reality check. The data is never perfect. A few of these leads are missing a required field. Maybe one has an email address that's just completely wrong. With that old all-or-nothing approach, this entire batch of 100 leads would be dead on arrival.
And here is the fix. I mean, look how simple this is. Just by adding that little comma false as a second parameter, you've enabled partial success. Now, the 90-something valid leads, they get created. And you've stopped a total catastrophe with just a single argument.
But wait, our job isn't quite done. The operation ran, sure, but now we have to be responsible developers and actually check the results. This next part is absolutely crucial, figuring out what actually worked and what didn't.
Remember that report card I mentioned? This is it. The system gives you back an array of save result objects. Seriously, this thing is your detailed breakdown. For every single record you tried to insert, there's a matching result object in this array just waiting to tell you its story.
So what do we do with this report? It's a really simple three-step process. First, you're going to loop through that array, looking at each result one by one. Second, for each one, you ask a simple question. Is success? Did this one record save correctly? And third, you just route the traffic. If it was a success, awesome. Grab the ID of the new record. If it failed, well, now we dig in to find out why.
Okay, this last part. This is what separates the everyday code from the truly professional, resilient systems. We're not just going to ignore the failures, we are going to turn them into valuable information. This is your playbook.
So for every record that came back as false from his success, there's another method waiting for you: get errors. This method is an absolute goldmine of diagnostic info. It doesn't just tell you that a record failed, it tells you exactly why it failed.
And here's how you get that info. You just loop through the errors for that one specific failed record. And inside this loop, you can pull out the specific error code, the actual error message a human can read, and even which fields on the record caused all the trouble. I mean, that's incredibly powerful stuff. So what do you do with all this detailed error information? You take action. First, you log it. You absolutely need a record of what went wrong. Second, you can automatically notify someone, like a system admin, that a record needs a human to look at it. And third, and this is for more advanced systems, you can even add the failed record, along with the reason it failed, to a special queue to be fixed and retried later.
And that right there, that's the whole story. It's the journey from code that's, kind of fragile and breaks easily, to a system that actually anticipates problems, handles them gracefully, and gives you clear feedback so you can improve. That's what intelligent, resilient data handling is all about.
So, here's the big takeaway. The next time you're writing code to handle a big list of records, don't just cross your fingers and hope for the best. Plan for reality. Instead of letting one bad apple spoil the whole bunch, you now know how to build a system that saves what it can and tells you exactly what needs fixing. The question isn't if you'll get bad data, it's when. And now you're ready for it.